Okay, let's dive into this. Welcome to today's Explainer, where we're going to look at one of the most audacious, literally breathtaking architectural blueprints of our modern era, the technical master concept for the radical transformation of Venice. For anyone who's fascinated by engineering, by history, or honestly just the sheer willpower of human innovation, this is an absolute masterclass in pushing boundaries.
So, it's the ultimate question, right? How do you lift a sinking, centuries-old historic city without it just crumbling into dust? What we're unpacking today isn't just your standard construction project. It is a literal heist against time, against gravity, and against nature itself.
Here's a quick roadmap of how this massive blueprint comes together. We'll start with A, technological rebirth, then move through Phase 1, dewatering Venice, Phase 2, the steel carpet, Phase 3, the megalifting system, Phase 4, identical reconstruction, and finally, Phase 5, the infrastructure revolution.
Let's start with Section 1, a technological rebirth. We're talking about a massive paradigm shift here.
You know, for decades, the strategy for Venice has essentially just been damage control. But we're now moving way past patchwork repairs into complete structural and infrastructural renewal. The goal here isn't just to buy a few more years. The goal is to keep the city completely dry, stable, and secure for hundreds of years. No more Band-Aids. We are talking about open-heart surgery for a metropolis.
Section 2, Phase 1, Dewatering Venice. It all starts with isolating the city districts.
Because, look, before you can fix a sinking city, you first have to block the water. The technical term they use here is Messa in asciutto. This is the highly calculated process of isolating and completely dewatering targeted city districts. And this is absolutely vital because the historic foundation sitting below the waterline, it isn't solid rock anymore. Over centuries, it's degraded into what engineers describe as Platea, which is basically a mushy, muddy mass. And you definitely can't build on a mushy mass underwater.
So how do they actually pull this off? First, they deploy these 2-meter-high mobile roll barriers that can stretch up to a 5-kilometer perimeter just to block the tides. Next, they drop in Larsen sheet pile walls, often referred to as tuura, to completely isolate specific canals. And finally, massive industrial pumps empty the water out. By creating these completely dry zones, massive, deep-level interventions finally become possible without flooding the whole worksite.
Moving on to Section 3, Phase 2, the steel carpet. This is where surgical precision really comes into play.
Now, what's really interesting about this phase is the incredibly tight spaces they have to work with. Venice is famously cramped, so you can't exactly drive a massive construction crane down a medieval alleyway. So the engineers devised this brilliant workaround. Step 1, they install modular steel pallets, literally carrying them piece by piece inside the cramped buildings. Step 2, they inject expanding polyurethane resin directly into the ground beneath. Step 3, this forms an inseparable, rigid foundation. By doing all this inside rather than digging up the outside, they completely spare the historic exteriors and streetscapes.
The result of all this is something called a Platea. It's a monolithic, rigid foundation plate created by literally gluing the modular steel and the ruined foundations together with that expanding resin. And this sticky, rigid Platea is an absolute game changer. Without it, the ground would simply buckle, and the brittle buildings would literally just fall apart during the immense stress of the next phase.
Which brings us to Section 4, Phase 3, the mega lifting system. Time for some jaw-dropping, heavy engineering.
100 meters. That is the height of the colossal exskeleton towers built for this phase. I mean, just picture that. 4 of these 100-meter towers are erected around a single building block. To make sure they can absorb the enormous loads of literally lifting a stone structure, they anchor them 15 to 20 meters deep, driving them right through the mud and down into the stable sand layers below the lagoon.
And the ultimate goal of all this heavy machinery? The blueprints put it beautifully. The structures are, quote, controlled and lifted with millimeter precision. It's such an incredible juxtaposition. You have these 100-meter towers and massive, highly stiffened rope and pulley systems all working in tandem to apply the gentlest possible force. This hoist system minimizes shear forces so perfectly that the incredibly brittle historic masonry doesn't suffer a single crack while it's being raised into the air.
Section 5, Phase 4, Identical Reconstruction. Let's look at fixing those old foundations.
So, let's step back and see how this builds out once you have a medieval building basically hovering in midair on a steel carpet. The old foundation? It's rotting larch and oak wooden piles just sitting in a mushy soil mass. While the building is suspended, workers completely tear out that failing organic material. In its place goes the new foundation, an identical visual rebuild, but using highly advanced, salt-resistant DMS bricks. And get this, these bricks are actually made from recycled lagoon sediments, guaranteeing centuries of lifespan because they're completely chemically resistant to salt and wastewater.
Speaking of wastewater, that brings up a very practical question you might be wondering about right now. What happens to the sewage? It's definitely the unglamorous side of city planning, but for a city surrounded by water, it is literally everything.
That takes us to Section 6, Phase 5, the infrastructure revolution. An absolute plumbing overhaul.
Because fixing the buildings and making them flood-proof just isn't enough. The city needs a total plumbing overhaul to stop old sewage leaks, which are locally called gatoli, from chemically decomposing the new foundations. That's where this number comes in, 15 meters. That is the starting depth of a brand new, deep underground tunnel network. Instead of dumping waste near the surface where it rots the stone, this new network runs safely through the stable sand layers, far away from the newly rebuilt historic foundations.
And this brilliantly illustrates how this invisible revolution works beneath the lagoon. Every building gets a vertical 20-centimeter pipe running directly through its new foundation. Natural gravity just pulls the waste right down into that deep tunnel system. From there, the sewage travels outward until it hits these 60-meter-deep ring-shaped collection pits located safely at the city outskirts. Finally, these massive pits are efficiently emptied by specialized ships. It's a completely sealed, modern waste management system hidden entirely out of sight.
But wait, there is one more thing. After all the insane heavy lifting, the deep tunneling, and fixing the buildings permanently at their new flood-safe heights, the engineers included this final, almost poetic aesthetic touch. Small stones and cushions are to be scattered across Venice. It sounds kind of bizarre at first, but it serves as a combined measure for physical protection and a delightful artistic decoration to visually round out the newly elevated city.
Which leaves us with this final thought. When you step back and look at the audacity, the cost, and just the sheer scale of the engineering required to pull this off, the 100-meter towers, the steel carpets, the deep sand tunnels, you really have to ask, is this radical rebirth the only way to save our history from the sea? It's a deeply provocative question, and as sea levels continue to challenge our historic coastal cities, the blueprints we explore today might just be the exact bold template humanity needs for the future.